Have you ever asked an AI assistant to book a meeting, check the weather, or pull data from your database, and watched it confidently make something up instead? That's the gap between a chatbot that talks and an agent that acts. The bridge across that gap is function calling, and today we're going to build it from scratch. By the end of this video, you'll understand exactly how large language models connect to real tools, why these systems break, and how to make them reliable enough to trust in production. Let's start with the core idea. A language model on its own can only produce text. It can't query an API or run code. Function calling works by giving the model a menu of available tools, each described with a name, a purpose, and a set of type parameters. When you ask a question, the model doesn't answer directly. Instead, it decides whether a tool is needed, and if so, it outputs a structured request, usually JSON, specifying which function to call and what arguments to pass. Your code intercepts that request, runs the actual function, and feeds the result back to the model so it can finish the job. Here's a concrete example. Imagine you define a function called get_weather that takes a city name and a unit, either Celsius or Fahrenheit. You describe this to the model in a schema. A user asks, "Should I bring an umbrella in Seattle today?" The model recognizes it needs live data, so it emits a call, get_weather with city set to Seattle and unit set to Fahrenheit. Your application executes that against a real weather API, gets back, rain, 60 degrees, and passes it to the model. Now the model responds naturally. Yes, it's raining in Seattle, so bring an umbrella. The intelligence and the action stay cleanly separated. The magic is really in the schema. The quality of your function descriptions directly determines how often the model picks the right tool with the right arguments. Vague descriptions like gets info lead to chaos. Be specific. Say exactly what the function does, when to use it, and what each parameter means, including valid ranges and formats. Mark parameters as required or optional. If a date should be in ISO format, say so. Think of the schema as a contract and a prompt at the same time, because that's exactly what it is to the model. Now let's talk about why these systems fail, because they will. The most common failure is hallucinated arguments, where the model invents a parameter value it doesn't actually have. The fix is validation. Never trust the model's output blindly. Parse the JSON, check types, verify required fields, and confirm values fall within allowed ranges before you execute anything. The second failure is the model calling the wrong tool or no tool when one was needed. You reduce this with clearer descriptions and, when appropriate, by forcing a specific tool choice rather than leaving it open. Reliability also comes from how you handle the loop. A real agent rarely calls one function and stops. It might call a search tool, read the results, then call a calculator, then a database. You need to run this as a controlled loop. Send the model context, get a tool call, execute it, append the result, and repeat until the model produces a final answer. Always set a maximum number of iterations so a confused model can't spin forever, and always handle errors from your functions by passing a clear error message back, so the model can recover or try a different approach. One more critical piece: idempotency and safety. If a function sends an email or charges a credit card, you do not want the model accidentally calling it twice. Add confirmation steps for destructive actions, log every call, and design functions so repeated calls don't cause damage. So that's function calling from the ground up. A schema as a contract, strict validation, a controlled execution loop, and safety guardrails around anything irreversible. Master these, and you'll build agents that don't just sound smart, they actually work. If this helped, subscribe, and I'll see you in the next one.